All right, first day of trigonometry, and let's review the trig ratios. Sine of an angle theta, that's pronounced theta. All right, sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Opposite over adjacent. And then the others are just the reciprocals. So we'll do the reciprocal of this and the reciprocal of that. And this is also where we get SOH, CAH, TOA, SOHCAHTOA to help you remember the ratios. And when we talk about opposite, adjacent, and hypotenuse, we are talking about if that's theta, then this is the opposite of theta, and that's the adjacent to theta, and there's the hypotenuse. If we call that theta, and we're going to talk about that one, then this would be called the opposite, and there's the adjacent and the hypotenuse. And these trig ratios are only for right triangles. Okay, so before we start, we have to use the Pythagorean Theorem to find the missing side. So we have a squared plus b squared equals c squared. And then we have all right. Here's theta. So that means opposite is 2 radical 14. And we want to have the hypotenuse, which is 15. Cosine is going to be adjacent, which is 13, over the hypotenuse. Tangent is opposite, 2 radical 14, over adjacent 13. Cotangent, and then we can just do the reciprocal of these. And let's have multiply by the radical, and we'll get 13 radical 14, and then it'll be 2 times 14. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Let's multiply by the radical to rationalize the denominator. All right, same question. Try pause the video and try that one. All right, we have the 2 legs, so we'll go 32 squared plus 8 squared. And that's 1088. It reduces to 8 radical 17. And then we find all the trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent adjacent over hypotenuse. Tangent, opposite over adjacent. And then we can do the reciprocal, so let's go ahead and do that. And then we'll do the reciprocal to get this one. We can reduce this 32 and 8, so that'll be 4 over radical 17, and it'll give us the secant. And then we'll do, this is 1 over 4, so we get 4 here. Multiply by the radical, 4 radical 17 over 17. Okay. So here's another type of question, and we will use cosecant to draw the triangle. We know cosecant is hypotenuse over opposite. So then we can draw the triangle with a hypotenuse of 6 and an opposite side of 1. So we can just pick theta. Wherever theta is, we know that the opposite of theta is 1. And the adjacent to, or the hypotenuse is going to be 6. And then we can solve for the adjacent. Let's call that x. This will be a 36 minus 1. And then we're back to the same steps. And we're going to find the opposite over hypotenuse. And once we do that, we can get this. And then we're going to do the adjacent over, the adjacent over hypotenuse. And that means we also have this. Let's rationalize the denominator. 6 radical 35 over 35. Secant. And tangent is opposite over adjacent. And then we can do the reciprocal here for cotangent. And we'll rationalize the denominator. Okay, same question, but now we have tangent theta is 1/4. Okay, so you draw the triangle and find the other 5 trig functions. Pause the video. We could draw the triangle however you want. It's just wherever the theta is determines where the numbers go. And if we have tangent is 1/4, then tangent is opposite over adjacent. So that tells us that the opposite of theta is 1. So here's theta, the opposite would be 1, and the adjacent is 4. And then we can solve for the hypotenuse. We get 17, and we will square root both sides, so radical 17. And we already know tangent, so let's do sine. Cosine tangent, we already know. Cotangent, secant, cosecant. Sine is opposite over hypotenuse. The hypotenuse is radical 17, so we'll do opposite over hypotenuse. And once we know that, then we can do the reciprocal. Cosine is adjacent over hypotenuse, 4 over radical 17, and then this will be radical 17 over 4. Cotangent is adjacent over opposite. Adjacent over opposite, and we also see that it's the reciprocal of this. All right. And here's another type of question. So find a missing side of a right triangle, and we have to figure out which trig function to use. So we have to label the sides and then look at what we want to find and what we know, and then find a trig function that has those sides in it. So let's label, this is the hypotenuse. This is adjacent to the angle. And this is opposite of the angle. So we know that we want to know the adjacent. We know the opposite. We need a trig function that has opposite and adjacent in it, and that's going to mean tangent. So if we need opposite and adjacent, then we need tangent. Tangent of 57 is opposite over adjacent. We could multiply both sides by x. Divide by tangent of 57. We get 6.5. So when you do tangent of 57 on the calculator, make sure it's in degree mode. There's a button that says mode. You just push that and select degree. All right. Pause the video and try that one. We label opposite, adjacent, and hypotenuse. So opposite is over here. 16 is next to, so that's adjacent. The hypotenuse is also adjacent, but we call it the hypotenuse. All right, we have adjacent and hypotenuse. Adjacent and hypotenuse. Which trig function has adjacent and hypotenuse in it? That's going to be cosine. Cosine of 24 is adjacent over hypotenuse multiplied by x and divide by cosine. Using the calculator, we get about 17.5. All right, pause the video and try that one. And we have to label the sides so we know that there's the hypotenuse. This is the adjacent, and there's the opposite. We need to have a trig function that has the opposite and hypotenuse. Opposite and hypotenuse, we must be using sine. Sine of 18 is 22 over x. X sine 18 is 22. And we get 71.2 approximately. Okay, and pause the video and try that one. There's the angle, so this is the opposite. Hypotenuse and adjacent. We want to know the opposite. We know the adjacent, so we want to use a trig function that uses opposite and adjacent. Opposite and adjacent means we want to use tangent. Tangent of 29 is x over 40. And on the calculator, we get 22.2 is approximately equal to x. That's it for today.